Here's the initial setup for energy conservation with a rubber band. The purpose of this lab, again, is to help us understand that the potential energy in a system, whether it's a rubber band, a spring, or an object on top of a hill, when you lose that potential energy, you can always keep track of where it goes. It's not destroyed. It may turn into heat loss, but it turns into another form of energy. It doesn't cease to become energy. So our setup is we have the rubber band attached from one leg of the table to another, and then we have an air disc. So as a quick overview of what you're going to do, we're going to find the spring constant of this rubber band. Then we're going to pull this back, and to a certain distance we're going to use 0.5 meters and 0.4 meters, and you let it go. Okay, with the air on, we're going to use our video physics to measure the velocity right as it leaves the rubber band, and we're going to show that the potential energy that I had back here turns into kinetic energy. And with my results, I may have just gotten lucky, but my results came out really close. That with the air on, with the air disc, it came out really close. That I didn't lose. Actually, mine showed that I gained some energy, which isn't impossible. So that's just a measurement error. So if I work this back, then we're going to use a metal 1 kilogram weight. We're going to pull it back. Obviously, it's going to have a lot of friction. Then we're going to let it go, and we're going to see how much of our potential energy we lose to friction before it becomes kinetic energy. And in this case, we'll measure the time and the distance here and find our average velocity and final velocity like we've done several times before. So that's a quick overview of what we're going to do. Now I'll give you a few little details. The first thing we need to do is find the spring constant of this rubber band. And you notice you'll have to take the rubber band off and run it through the loop on your air disc, and then you'll pull on the string. Hopefully we'll have this reinforced. If it comes loose, we'll just have to put extra tape on it, because the reason you don't just hook the force probe directly on the rubber band is because when you actually do the experiment, the rubber band is going to be wrapped around the air disc, which changes the angle, and you do get a different spring constant doing it that way. So you'll just hook it up this way, and then you just pull it back a half a meter. You'll need to make sure that your probe is on 50 newtons, because you're going to get more than 10 newtons worth of force in this lab. You can pull it back a half a meter under the table if you want, or you can put a half a meter mark out here. I'm going to turn the air disc on. You want the air on when you measure the force. So I turn the air on, then I hook it up like I had it before, and I pull it back. Then I hit the play button. You want to make sure you're not pulling down into the floor or up. Keep that as level as possible. Hit the play button, let it run for a little bit, and then find the average, the mean of the force. And that then you can use that, because you know your distance is 0.5. and you have your force, so you can find your spring constant. We've already seen this part of the video before, but when I pull it back, it's okay to just use your hand, because I don't care about this time. It doesn't matter. All you want to do is make sure you let go quickly, so you're not holding on to it as the spring, as the rubber band's pulling it. So you can just pull it back that way. You don't have to pull on the string. In fact, it's hard, because the rubber band will make it hard to do that. So you can just hold it this way, and you let it go, and your video physics should be right here, because I don't care about this time. In fact, for the air disc, I don't really care about the time here. I'm just going to take my 2 blue dots, and I let it go. And then you'll do the exact same thing with the 1 kilogram weight. If you want to do it all at once, that's fine, because you don't use the data from one to work on the other. So I let it go. Only on this one, you'll have to video this distance, which I'll show in a second. So again, here's the picture you'll need when you video the weight. You let it go, and you'll need to have this whole distance. You need to measure that distance. I have a 0.5 and a 1 meter mark. It makes it a little easier to measure it, but you don't have to. I used the 0.5 meter mark so I could to help me so I could pull it out when I found the spring constant. And you do that time. We've done that numerous times, so that should not be a problem. The closer you can get to your video physics, you only need, with your video physics, you only need 2 blue dots. This thing is going to fly. It's going to be hard to measure, so I'll show you what. So you can see it's really blurry. Now right now it has, this is my rubber band was right here. Make sure you don't put a blue dot until your disc has cleared that rubber band. So there's my first one, there's my dot. What, hopefully yours will come out the same way. You got that little black spot in the middle that you can put right in the middle of that blur and assume that's the best average of the middle of the disc. So I put one there, and then I put one there. If you're too close and you can't get the second dot, then redo it. It just takes a minute because we're not collecting a lot of data in this one. And just to illustrate again how fast that goes, so it's a little tricky, it just flies. Okay. Once you've got your 2 blue dots, again we go open the data in graphical analysis, and you go to table. If you only have 2 blue dots, these 2 velocities will be the same, and again you can line up in your your video physics, line up your coordinate system to where the video goes right along the x-axis. But anyway, here's my x velocity, and that's what I'm going to put in my table. One last quick reminder is you notice I've got this, I moved the XY coordinate system. I put the origin right on the middle of where I was going to put that blue dot, just to make your life a little simpler. And I made sure that my x-axis lined up with the movement of the disc. The other thing is you need a reference. You can either put a ruler down and do it before you release the object, that's fine, or you can just measure how far it is from this crack to this crack, which is what I did. But you do have to put the reference values in. So let's take a look at our notebook data.